Yeah, and since we are less people now, I guess we can also be more interactive, right? We are here to present some of our ideas or some of the examples in the industry. But you know, if you have good questions or comments, feel free to interrupt so we can have a real round table without any round tables. Yeah, no,
it's not wrong, but okay. So Peter?
Yeah, I'm Peter Antoniak. How many of you have been in the morning session? All of you?
All of them.
So I don't have to introduce myself too much. Maybe I can tell you a bit of my past, because in the presentation I didn't share that. Yeah, if I'm not there, I'm not there. I'm in the picture there, so. So yeah, I graduated in the 90s in industrial automation, and then I started my doctoral studies in virtual reality, started back then, and then I moved into augmented reality quite early. The patent, or this idea with the hand interface, is from '99, and I finished my doctoral in 2005. That means also that I had part of my career in the academic world, and then I moved into the industry where I did a couple of jobs in consultancy, product development, mobile phones, and now in Augment I'm the CTO of the company.
Okay, hello everyone, I'm Fabien Dumont. I'm working for Airbus, and I'm the Holographic Academy leader for Airbus Defence and Space. So just to explain you a bit what is the Holographic Academy. So 3 years ago now we created the Holographic Academy to unlock, support and deploy mixed reality in Airbus. And so it is a transversal service. We have one academy per division. We have 3 divisions in Airbus: commercial aircraft, defense and space, and helicopter. For those who were here last year, Alexandre Godin participated to the seminar. It is one colleague of mine in the Holographic Academy on the commercial aircraft part.
So my name is Grégory Roy. I'm a human factor engineer, and I worked during almost 9 years as a consulting in human factor, UX, and ergonomy in an innovation context for company. And since 2 years, I'm a business developer in Bertin to now not making studies, but create studies with other company and find with us how you can study human factors and make human-centered design in innovation.
Okay.
So, before we start, how many of you are actually from the academia? Okay, and how many are from the industry? So the academies are very interested in hearing about our.
Oh, it's good. So just so we choose the title "Why Mixed Reality Improve the Industry." So just as a reminder, we will not make a long speak about that. Just a reminder that mixed reality is, so you have the virtuality continuum, all that's behind reality and virtuality. And why do we think that it is important for industry? Because currently mixed reality are identified like the fourth digital revolution after personal computing, internet and mobile. And we think that in few years, maybe 5, maybe 10, we don't know exactly, it will be part of your daily life. Everybody will have device at home, or maybe just glasses with augmented information. And for industry, we have to use this like we use smartphone, tablets, and computer. So
Yeah, so then I put up one of our slides that we usually share with investors. So these are some of the industries that ourselves we have done work for those segments. I have been asked questions. Actually, this is a funny story because a couple of weeks ago I met with a head of research of a big company. I got a strange call from one of our ODMs that they make smart glasses, and they were like, hey, you are going to get a call from this guy, so please make sure that you present about the area and so on. So I get this guy visiting our office, and his problem was that he wanted to use mixed reality, augmented reality in his company, and as a head of research, he had to have the answers to present to his management, and he was like, I have no idea. Are there any use cases for real for the industry? Because I tried a lot to find out, to Google and find out, like, are they real? And he could not find much, And I was like, yes, I know. That's our problem also. It's not that they don't exist. They exist, and we have done them, but we cannot talk about them. Because in that way, the industry protects them, their IPR, right? If they find out that something works, great, they do it. If it doesn't work, well, okay, we cannot talk about it because maybe somebody else tried and invested the same time. So what I can tell you is that thus far we haven't found an area where you need IT or you're using IT already and you cannot use augmented reality to improve. I don't know about you, but at least I haven't found like, okay, those guys are using the IT, there's no point for them to use mixed reality.
No, that's right, because so one of the mission of the Holographic Academy is to map all the use cases we have in Airbus, and since 2 years we only get more than 300 different use cases all over the company. So some of them are close, but so that means that we have a lot of area where we can use augmented reality.
Yeah, and in some ways I compare, because I come from old school of mobiles, and there was a point in time when, like we had the desktops and then the mobiles, the tablets started to come, and then people were wondering about how it will end and what's the point to use a tablet, right? And where we are today, right? So it's it changed a lot of the way that people are working. And please, yeah.
So when you say there's no possible, you didn't encounter a field, but what about programming and coding and working with text in general? Do you see a way of how that can be improved with augmented reality?
I have one guy that he has his screens, and then he extends the screens with this kind of augmented reality displays. So it will get also there when these devices get more common.
Yeah. And higher resolution, I guess.
The resolution is there quite much. So earlier I was saying the R9, it's 1K per eye, so you have quite powerful now. It improved quite much. Yeah, so the point of this picture is to show you how simple it can work sometimes. The whole idea here is that the worker has to see some data, right? So in the past, they had a machine that was showing this, how much pressure is in the hose and what kind of volume it's the fuel pump putting there, and he had to stay with the machine there and look at that. At the same time, there was another one to keep the airplane in check and so on. So by just putting a display on his eye, You simplify the whole process, right? But you call that. You cannot call it augmented reality because it's really just putting a display, so you call it assisted reality. But it's where it can help. Just basic stuff. Putting the display where the eye of the workers, right?
Yeah.
And it enhances that. I think they measure, in some cases, not in this case, up to 50% of increase in productivity of those workers. Just because displays here, they don't have to look, they don't have to search for it. So.
Yeah. So what we are doing at Airbus. So just to explain you a bit, this is the past. Previously, the worker on the aircraft assembly line have an instruction set on paper, like when you buy your furniture in the IKEA shop. You have the how to build your table or whatever, and it's not so easy. And it was what happened during years in Airbus. And why it is important to change that is because we had the discussion just during the coffee. Currently, if you know the automotive industry, a car is built at 90% by automated stuff, robots and so on, and only 10% of manual tasks, maybe less, so it's a rough idea. For an aircraft, it's the complete opposite. It's more than 90% of manual tasks. So if we can improve this way of working, we will be able to produce aircraft faster. And for those who know a bit the aircraft industry, it's a big issue for us because we are not able to produce the same amount of aircraft we sell every year. So for example, last year Airbus built 700 aircraft, and they sell more than 1,200. So that means that we need to produce aircraft faster. So more than 10 years ago, we start to work on augmented reality with tablets, and you can see the mirror application. And we use this application for quality inspection. So for example, we use, so you can see the tablet, and we have a specific camera with depth sensor and so on. And with that, we are able to align the real aircraft and the digital mock-up, and to inspect if each component are at the right place with a millimeter precision. And with this tool, we go from 2 weeks to inspect the full aircraft to only 3 days. It was already a big gap. It's perfect for quality inspection, but we cannot use it for manufacturing, for building the aircraft, because the worker needs to have the hands free. So the next step will be to have, so sorry for the photo is a bit cut, will be to have a digital work order. So I mean to display where you have to work, exactly when you have your IKEA table, to say where you are to put the screw, where you have to put this part, and not by a drawing, but directly in space. And for that, we develop a prototype on HoloLens, and I will show you a small video. Normally, yes. So this is exactly what can see the worker. The yellow and the pink cable are virtual one, and it is where you have to install the current harness. And you can see all the parts you have to, where you have to clamp this harness with the part number related to that. And with this application, the workers are able to work very easily and know where you have to work, what you have to do, and not to have to translate all the 2D information in his real space. And we made some tests with that, and we are able to say that currently for harness installation on an aircraft, we can save 30% of the time. If you know that in an aircraft, in the smaller one, the A320, there is more than 100 kilometers of harnesses inside the aircraft. So it's already a huge amount of time we can save. And after that, we will plan to apply this technology to other step of the aircraft building. Because currently, for all what is like drilling, riveting, and so on, the accuracy of the HoloLens is not enough. There is no device that are enough accuracy to do it now, but we expect in the next few months, next few years, to have good device for that. Sorry.
I had a question about this kind of application. So, is it an online application or is it connected online? Is it connected to your IT database or is it quite isolated?
Currently, this is completely isolated because in our timeline, during the 2 previous years, we were developing prototype to find which use case can have added value for the company for the process. And now for this year we will work on the industrial phase, so how to connect the HoloLens in our network, how to get information. So currently we have a server where we can store all the work order, and we are connected to this server by Wi-Fi, but this server is not connected to the Airbus network. This is the work we have this year to certify HoloLens on the security point of view, on the health and safety point of view, and all this stuff to be able to work in real condition in Airbus.
Because I saw an issue, or it's not an issue, I don't know, but to determine, in fact, to include the use of the VR in the process and get the information associated to the phase of building, the phase of the process, and get the appropriate task, the appropriate 3D models, and so that it is the beginning of the question before, say how you get this information, you collect this information from your IT system into your application to correctly respond to the need of the...
Currently all the aircraft have a digital mock-up. We use the CATIA application from Dassault System, and we also have all the building information. All the work order have it depends on the aircraft. Sometimes it's on CATIA, sometimes they use other tools like Delmia or other own tools. But all the procedure is already described digitally. We have all this information, but currently we export them on our server and we create the procedure like that. But so normally this year or beginning of next year we will have the real link.
But the industries usually have it connected. The whole point is to connect everything, the machines, the workers, and So in other, it's the key is to have it connected. Like we have this, what I was earlier saying in my presentation, these workers inspecting. If they're not connected, there is no way he will get that information. So, and then there is the question, what are they using for the to connect? They use Wi-Fi, Bluetooth. The industry has changed compared to 10 years ago. They would not allow Wi-Fi on the factory, but now we even saw like they are quite open to this, even though it can affect. So
I think we have a.
Have you tried to use a projector in connection with image processing or computer vision, so you can project the following step of the work, and with image processing or computer vision, check the previous step of the assembly and so on, which is something which is different from using HoloLens.
I agree. So, for example, the mirror application have a module to work with simple projection with beamer and with laser projection. But so we have some issue with that because okay, the projection with laser or with beamer is very accurate. We currently we cannot get this precision with any other device. But the time to install it, because you have to calibrate your beamer, your laser, you have to be very accurate for that, and the space you need, because you need to find a place to put the laser or the beamer, where when the worker work is not between his area and the beamer, and when you are inside an aircraft, it's very difficult to find a place like that. So that's why currently it works very well in labs, because we have just a part of an aircraft with a big room, and we can place the beamer where we want, and it's okay. But for industrialization, currently we have some issue, and that's why we didn't go through.
Did you try head-mounted projectors? Because they are now micro projectors, right? So
yes, but so when when you use the fixed projector, if you hurt the projector, it can realign automatically, but that takes some time. So if it is a head-mounted projector, it's very difficult to be very precise.
But it's not more difficult than with smart glasses, is it?
Yeah, but so, as I said, currently with smart glasses, we have not enough precision for drilling and for riveting, and it will be the same thing with head-mounted projector. And for harnesses, head-mounted display is perfect, like the HoloLens. And what we want to do now in Airbus, because during years for Mira and for other applications, we developed our own technology, because so 10 years ago nothing exists on the market, so we were obliged to develop our own algorithm to integrate specific camera with tablet and so on. But now, since 2 or 3 years, as the device is already on the market, we try to put more energy on the use cases, on the experience, instead of the technology itself, and we have just to buy some HoloLens, some HTC Vive and so on, so for example, in 15 years before, we only cover 5 different use cases. Since 2 years now, we develop more than 25 prototypes. So it's an important gap.
Excuse me, how do you evaluate the user experience?
Sorry.
Take the version from another. How do you assess the user experience, the work experience?
So in fact, the workers are involved since the beginning in the process. So that means that they test the application since more than 1 year and a half on the file. So they test a version, they try to do some work with, we get their feedback, we include the feedback
is from the worker himself.
From the worker, directly.
So sort of interview questionnaire.
Yeah, exactly.
Not
So
by observation, not by a third party who's observing him, achieving the task and assessing the workflow of the...
No, it is directly from the workers, what they're feeling, how they
Well, we had a customer that did this very extensive user experience on them with different worker groups, like young workers and old workers, how they feel about the technology, how they operate it, what kind of mental load they have, what kind of interaction they find, what kind of like the brightness of the display. They are very extensive. So they are, this kind of...
usually the perfect team to improve this technology from update the versions. Does it include someone who's IT expert, usually right? The UX expert, and I don't know, cinematographer. I don't know. Do you require usually in your team? Do you need in your team someone who's professional from the media industry, from the photography industry? Is he a must? Is he a part of your team? usually?
If in this case, I don't know if they had like photography, but they had user experience group in their company. But of course, you know, there are other companies that don't even have an IT guy, so but they still have the same problem, and they still need to use these
No,
new
I'm talking
technologies.
about the AR team. Do you have usually, when you compose an AR team, augmented reality team, to find a solution for a company? The team is usually formed of an IT expert, augmented reality expert. You have someone from the media industry.
So, yeah, maybe Gregory can answer
Yeah.
because this is the.
It's a really good link to my speech, so I can take it. As a company, consulting company in ergonomy and human factor, we work with mixed reality and virtual reality in two ways to help company industry to work with. The first way is to use virtual reality to make user tests, and I will show you some example later. We do with a PSR. But the other way is a use case question, and it's a big deal right now because have a helmet of virtual reality is really easy and is cheap. But now everyone have one, and everyone asks, okay, what can we do with that? And the problem is I can do anything, quite anything, but if I do something with that other way than I actually do, may I gain time, money with this kind of device, AR, VR, in my consumption, in my factory? So we work hard because the use case is one of our big attention point. Actually, you know, Peter tells Peter is an expert in hardware, but you work on a big part of time on the use case with your client. So currently, it's the point. It's when you make this. This is a design thinking on human-centered simplification of process to make something in innovation, services, product. You have empathize, define, etc. So at each step of this project, how I can use mixed reality or virtual reality to help us to go faster and go better. So it's there is not one response. There is response for each project of each company. The issue of Airbus is different than issue of automotive because, like Fabien says, they are not manufacturing product in the same way. So you can put the same technology at the same moment of your building product. So many companies work for that, and to help us to work faster, we use our knowledge of human and virtual concept to help them to make project better and faster.
If I can add also something. By now we already know what works also. And I guess for you in Airbus, you already know what works. So you don't spend so much time anymore with this kind of fine tunings because you have done this for many years and you gather enough knowledge, right?
I would say it really depends on the use cases. Okay, for production, so we already know a bit what's it's okay. For other use cases, it's different, and we have to discover some stuff. And maybe to answer a bit more to your question, so our team in Airbus, so we have different kind of people. We have no people from media or from photograph, but we have UX designer, we have ergonomics, we have developer, we have artists, 3D and 2D. And for sure, not always, but we have also IT specialists and developers and so on. So, and we have some part from the customer, so internal customer, sometimes it's production, sometimes it's human resources. I have other project after that. So we have a very large skill team. And so that's why maybe we don't have all the skill, but we have a lot.
No, I guess we move to the next slide. Or?
If you prefer, I can keep this one. This is your slide.
Yeah, well, we put it to show you some of the cases. These I already talked in the morning, but there is also medical, which it's outside of the Industry 4.0, which was my keynote was all about. And so you have these kind of industries also that they benefit from this. And how do they do it? I mean, in this case, it's because they have to use gloves, and touching screen sometimes is not a good idea. So you can use this technology to fix that problem. But also in pharmacology, they need a very precise record of what happens in the batch. So they need to know the traceability of the product, right? So which worker did what, and these kind of tools allow you, because the worker, when it starts the shift, they identify to the glass, and then from that moment on, whatever they do, it's only with the glass, and then they have this traceability working automated for them. In the past, they had to use barcodes and other ways to do the similar things. So, and of course, one aspect that we haven't discussed is the fact that with those glasses you have also other sensors. You have the camera that can be used, but you have also the inertials on the head, so you can also track what the workers are looking, if like how many steps they have done, are they tired, you can also improve those. Here it's the examples of using the just the hands to interact faster, so they don't have to carry up the control pads. Sometimes they like to be hands-free more, so they use this kind of approach to control the equipment. And here to change parameters, this use case was they had a very long machine, and the control panel was there, but they had to control the drill on the other end. And of course, in the original machine had a long wire that they had to drag with the joystick, right? So using this kind of thing, it's also safer, because you don't get the wire there on the floor that other people can knock it down and so on. So it improves also the safety, which is another aspect that we haven't talked too much because of the time, but it improves a lot the safety of the workers by just removing either the equipment or informing them about some of the steps that they might forget. We have also cases in construction, where they get information, and they get also this kind of safety warnings for the constructor workers. Your floor.
Yeah. And so, as I said, we have a lot of different use cases in Airbus, and so this is two other. It's not production, it's not manufacturing, it's more about learning and training. And it is two projects we developed last year. The first one is it is a project to understand how we can use augmented reality to improve the learning process. So we did it in partnership with Singularity University in California. And in fact, the idea is, so everybody have a different way to learn. So some prefer read books, Others prefer to listen a teacher, others prefer watch video on YouTube, or some others prefer to practice. And currently, all the training, all the classroom are exactly the same. You have, like today, we have a screen or a board with a teacher that explains you how to do it. But with augmented reality, we can adapt the content. We can have a virtual coach that knows you because it's inside the device, and that can provide you the right content to you. So if you prefer to read, it will provide you some text. If you prefer to practice, it will provide you a kind of small exercise like that, where so it is a lesson about the basis of aerodynamics, just a picture, and just by trying, you can see the different effect of the different geometry in an airflow. What happens if you put a cube, a cylinder, or an airfoil, and you can easily understand why the wings are the best geometry to fly. But so it is just a picture. And the second one, it is one we developed in partnership with Japan Airlines, how to train the aircrew of the airline to use our aircraft. Because currently they have specific courses, but they have to ground an aircraft, and it is very expensive for the airline. And we are happy to say that this is one of the first mixed reality applications, because with exactly the same application, you are able to use it on a chair in virtual reality or on a real cockpit in augmented reality with the same application. We don't have different the binary. This is exactly the same one. And so the idea is, so you can see, you can find it. There is some video on YouTube about that. We can guide the people. So this is how to start the engine of an A350. This is more than 120 different steps. So this is not so simple like a car. You have just to turn the key. No, for an aircraft, this is completely different. And normally, you have to put the pilot or the technician in the cockpit, and he has to learn each step, each button he have to check, each button he have to turn, and it's very long. And at the time of aircraft is very expensive. They don't have a lot of try and so on. Here in virtual reality, they can train themselves as long as they want. And after that, they can go directly in the aircraft and having the same information. So that means that without touching anything, they can train themselves, but very quickly inside the aircraft. And obviously, when you are in the real cockpit, we don't display the 3D like that. we just display So we are able to run it with a VR headset. So here we have the VR mode in the HoloLens, and we have the AR mode in the HoloLens as well. So that means that if you are in the room here, you will see the mock-up of the cockpit, and if you are in the real cockpit, we will remove the mock-up and we will align directly on the real button.
And how do you manage the twins, the digital twins with the real twins to make it correspond and provide the right information in the right place?
Oh, currently for the training stuff, we have a full simulator of the aircraft. So that means that normally when you push a button, you have the exact results in the simulator. And obviously, when you use this application, you don't use the real aircraft, because here you have you can fail. So there is no. We talked before about the safe place. Here you can fail. You can make some mistakes. There is no incidents on the aircraft. You cannot break the engine. You are free to try to do anything. There is several steps with full help and without any help. And in fact, as we have all the 3D data, we are able to generate the full cockpit, and after that we have a specific simulator for the behavior of the aircraft, of the hydraulic system, electric system, engine, and so on.
for the teaching application, did you find any specific advantages compared to, say, a web page that is has the same content?
Yes. So first, the web page will not adapt to your first to your space and not to your way of learning. So you will have to choose. And second thing is no, because we have, so it's not only text and so on. We have 3D. So we in this one we develop 3 different lessons. The first one is, so because we imagine for this prototype what could be the lesson for a newcomer in Airbus. So the first lesson is what is Airbus, different site, different products, and you have a lot of information. So that means that in the product you can see the aircraft in front of you, you can see different information about that. And if you don't want to read this information, you have a virtual coach that explains you how of the aircraft. And if you don't want to listen the virtual coach, you can have a video that show you and all this stuff. You cannot have an aircraft in 3D on a virtual patch. Or in 3D yes, but you cannot turn around this aircraft. The second lesson is about basis of aerodynamics. So we have a lot of 3D stuff like this one. And this one, so you have an airflow in 3D. So like you put the stuff in a real, I don't know the name in English, where they try the car or the aircraft. The wind tunnel, exactly. So we can show that with virtual or augmented reality. We cannot show that with the same freedom on web page. And the third lesson is a group lesson. So that means that you can a real coach this time can redo more or less the same module that you have in the second lesson, but it finishes with a group exercise. So the real coach are able to draw in your space an air path, and the students have to follow this path by managing the aircraft. The only thing is each student have only one command of the aircraft. One can deal with the yaw, or the other one with the pitch, and they have to we work together for that. And same thing, this is an experience you cannot have on a web page. And just to illustrate all the added value you can have with augmented reality. So I know that if you just want to have the specification of an aircraft, so there is no added value to display it on another lens. I agree with you. But so we try to present them in a different way. So that means that the learning is better because the experience it's good. It's better than just a web page, and it's more engaging for the people. Okay.
So, as I say, we work with PSR since many years, and we help them to take ergonomy and human factor at the beginning of innovation or conception. So they need to make innovation, but in automotive industry it's really difficult to choose the good one. And we speak with them, and they say, okay, now to 2025 we've got 5 concepts we really want to try to test, to make user test with, but we've got a problem. To make one prototype, the cost is 200,000 euro, so we cannot make it. So how can you help us with this problem? So we work together to make a virtual cockpit of this concept, and to work together to say, okay, in a virtual world, what type of user test can we manage? What KPI of user can we keep in virtual world? So we work together to make user test in concept, in virtual concept. And the good thing of it, it's all concept can be stored only in one computer. So it's quite easy to move, and so we keep this opportunity to make international tests, and we made the same protocol and deploy the same protocol in Paris and in Shanghai at the same time. So we can see how people react to this concept and see the gap between French people and Chinese people in front of this concept. And it's really new for them because it's a early stage of design. They can have user insight and international user insight. It's quite an issue too, because Chinese don't like the same concept as French people. So you need to make choice because you need to make the same car for worldwide. It's another problem. But for us, virtual tool, because it's a tool for us, really help to make user tests, really help to make human factors. For other people, like Airbus or other people who take care of human factor in their product, we can put people in situation of good immersion situation and have quite good stress. Because when you study human factor, if you want to see mistake, you need to have stress, and you need to have the good stress. If your user in simulator just thinking, okay, I'm a simulator, so I can have problem, they never make mistake. So you cannot do human factor with this mindset. You need to have the mindset of, I'm really driving car, I'm really in the real situation. So virtual reality help us, because virtual reality is really good to immersion, to make reflex, good or bad. So we hardly work with automotive manufacturers, French manufacturers, to try to understand human in virtual reality concept.
So I think now we are in the conclusion. So the beginning was why mixed reality improved the industry. So I think that we have already some results, not only us. So because just previously I talked about the 30% of time saving we're using augmented reality, and it's easy for me to say that because few weeks ago Boeing said exactly the same thing. They are testing the augmented reality for harness installation, and they find exactly the same figure behind. It's more or less 30%. So that's why we can say that with augmented reality we can increase the safety. So we talk about that. We can put some alerts. We can increase the quality of the work. We can increase the engagement of the people, and also we can reduce the time to produce, time to design, time to deliver, to react, and also if we reduce the time, we can also reduce the cost. So I don't know if you have something to
So
add.
that's why.
Yeah, that's why. It's important for us.
Okay. Is there any question? No? Yes?
You talked about safety and workers wearing the glasses, and especially the HoloLens. How long can they wear it? I mean, when I'm wearing it in the lab, maybe after half an hour my nose hurts.
About the nose, it really depends. So I don't know how many times you tried the HoloLens. Because normally when you have when you know how to put them, so you use and you don't put it it on your nose. This is this stuff, and you have the I don't know the name, but you have the strange on the top. And normally you don't put it on your nose. But so to answer to your question, so currently we have some study with health and safety and union and so on. And so the current recommendation is to use it between 1 hour and 1 hour and a half, with after that 15 minutes of rest. This is the current status. This is not definitive. The studies continue, and after that we also have other way to mount the HoloLens. A few months ago, Trimble released an helmet, an industrial helmet, where you can put the HoloLens. So that means that you have not the normal straps. You put your helmet like a normal helmet. And we made some tests also in Airbus. So because in Airbus they have some hats, some hard hats, and so fortunately the HoloLens match really well with this hat, and so if you put it like this, all the weight of the HoloLens is all over the hat, and it's not so uncomfortable to use. So
No more questions?
And then the devices are improving constantly.
yeah.
So.
Okay. Thank you, guys. Okay, so now